Hello Padit, my name is Anjani and I'm a member from Group 3. And in this video, our group will explain about PLC in Industrial Automation and Robotics subject for final exam. So our group member are Anjani, Brian, Giovanni, Guthridge, and Harvey. I will explain about the introduction of PLC. So, automatic car washing is a PLC-based project. Using conveyor, the first car washing system was opened in USA in 1940. This has hoist system, which was used in pool system. Nowadays, latest advantage and science have made it possible. This was the replacement of pushing to achieve great reliability and efficiency in the automatic car washing system. PLC is an automation which plays a very important role, and this conveyor course is very common in industrial countries. But in the conveyor Pratsi, having drawback that we cannot clean up the downside of the car, and we are using the pressure cylinder to lift the car, so we can clean the downside of the car in our project. The benefit using PLC is a director which can power most of the machines very straightforwardly, and it is very easy to step up a program and install it. The programs written in a letter language can be confirmed and start before putting in place, and also it can be abbreviated at any time without alarming any physical setup of the project. The best part is if the SME change are made in the previously installed program in PLC such that it does not require any typical wiring or rewiring.
Hello, my name is Harvey from Industrial Engineering. So in this presentation, I'm going to explain about how this car washing system works. So what is car washing system? Car washing system is in an automatic car wash. You drive into the car wash area and park the car in the wash bay after turning off your car and then just leave it on neutral. So the system will work by itself. So this is the process flowchart of the car washing system. The first step is detection inside the car wash bay. So the vehicle detection at a car wash is essential to verify that vehicles are correctly positioned in the car wash bay, monitor the flow of traffic through the car wash, and trigger the next step such as opening and closing entry and exit doors. And then washing with water. So washing with water, initially the vehicle is placed in the conveyor belt. A proximity sensor is placed in the starting point, and when the sensor senses the vehicles, the conveyor starts to rotate. The vehicles will also move along with the conveyor. When the vehicles is sensed by proximity sensor fixed at the entrance of the system, the conveyor stops its movement and the sprinkle will start to sprinkle water over the vehicle. Here, the dust particles present over the vehicles is removed using spraying water over the vehicles. Also, the mud which will be present in the areas of wheels can also be removed in this method. And then the next step is washing with foam. In this process, after the removal of the dust from the surface of the vehicles, the conveyor moves along with the vehicles at a distance of 30 centimeters and is programmed by a time delay of 10 seconds. Now the water along with the soap or detergent is sprayed over the vehicles, which is used to completely wash the vehicle cleanly. And then after the program time delay, the conveyor will be stopped for this process. Also here, the time delay is required to spray the soap water over the vehicles to clean the vehicles completely. And after that, cleaning with curtains. This process will make the vehicles completely clean. And then the last step is drying using fan. The PLC will automatically dry your car or your vehicles for a certain time or second. Okay, so this is the block diagram. So what is it? So the block diagram of the proposed system includes PLC, which is used as the controller unit, start switch, proximity sensor, which is used for the detection of the vehicles. The output module includes the conveyor belt, nozzles for fresh water flow, detergent water flow, and again fresh water flow to clean the vehicles, and the curtains to clean the wet over vehicles. So a programmable control consists of two basic sections: CPU, or central processing unit, and input or output interface system. So this is the central processing unit. The CPU is the heart of the PLC. The CPU reads signal and follows the instructions that program has stored in memory. As a result of solved program, the PLC turns output or field control device turn on off. The CPU consists of following three parts: processor, memory system, and then power supply. And after that, this is for the input-output interface system, the sensing session, input session, controller, programmer, output, session, and then field hardware devices.
Okay, for the next part, we will talk about the components. There are 9 components for our experiment project. There are PLC, motor, relay, conveyor belt, solenoid valve, power supply, proximity sensor, temperature sensor, and heater. Next, we will talk about our components one by one. Okay, for the first is the PLC. PLC, or a programmable logic controller, is an industrial computer control system that continuously monitors the state of input devices and makes decisions based upon a custom program to control the state of output devices. Almost any production line, machine function, or process can be greatly enhanced using this type of control system. However, the biggest benefit in using a PLC is the ability to change the replicate the operation or process while collecting and communicating vital information. Okay, next are the motor. An electromotor, like in this picture, is an electrical machine that converts electrical energy into mechanical energy. Next, relay. Relay are the switch which aim at closing and opening the circuits electronically as well as electromechanically. It controls the opening and closing of the circuit contacts of an electronic circuit. When the relay contact is open or NO, the relay isn't energized with the open contact. However, if it is closed or NC, the relay isn't energized if given the closed contact. Okay, next one is the conveyor belt. Conveyor belts can transport products either in a straight direction or through directional chains and elevation. The purpose of the belt is to provide control movement of the product. Belts are designed in a different size. System used to run the belts operate in different speed range. Next one is the solenoid valve. Solenoid valves are control units which, when electrically energized or de-energized. The advantages of the motor is can be used in domestic service station, as there is no compressor and number of loud noise. At the domestic workstation, if no compressor is there, then this will also with no sound pollution. Next one is the power supply. Power supply is an electrical device that supplies electric power to an electrical load. The primary function of a power supply is to convert electric current from a source to the correct voltage, current, and frequency to power the load. Okay, the next one is proximity sensor. Proximity sensor is a sensor able to detect the presence of nearby objects without any physical contact. A proximity sensor often emits an electromagnetic fields or a beam electromagnetic radiation, like infrared for instance, and looks for change in the field or return signal. Okay, the next one is temperature sensor. Temperature sensor is an electronic device that measures the temperature of its environment and convert the input data into electronic data to record, monitor, or signal temperature change. And the last one is the heater. An electric heater is an electrical device that converts an electric current into heat. The heating element inside every electric heater is an electrical resistor and works on the principle of joule heating. An electric current passing through a resistor will convert the electrical into heat energy. We will talk about the advantages about each components that we discussed before, like PLC and many more. Okay, the first one is the PLC. The advantage is the entire system is automatic, therefore no need of manpower. The PLC entirely works digitally. It needs only mechanical assembly. Next one is the motor. The next component is the relay, and the advantage is less maintenance. It means the very less maintenance. Like as we use the PLC, this is more durable than other electromechanical system. The next is conveyor belt. The advantages is comparatively cost of system is less. If a system is more durable, then its life is also as higher, and as per the consideration of life, the system have cost effective than other. Next one is solenoid valve. The advantages is no more space required, no environmental pollution, and the model of PLC is very small, so it doesn't require large size. Next one is the power supply. Advantage, of course, it will diminish manual power. Next one is the proximity sensor. The advantage is to proper exploitation of foam and water. And then there are temperature sensor. The advantage is easily operated system, and the last one is heater. The advantage is consumption of time is less in washing. Okay, next one, we'll talk about the application of our experiment module. For the first is car manufacture. Like in a car manufacturing companies, it will help in the final assembly of car. The next one is in a service station. Of course, it's very helpful for service station. Next one is for car workshop, like for help in car replacing and maintaining the station. And the last one is car bodybuilding industry. It will help the car industry, like for car when we want to build the body of the car, we can the experiment it will help the experiment like in industry, and it will help in the building industry.
Hello everyone, my name is Brian. Now I want to explain the module 1, module 2 and module 3. First we click the module 1 and the screen will appear like this. The purpose of this module 1 is to understand how PLC works. And we also need to understand what is the basic ladder diagram programming. And we also learn what is normally open, normally closed, latching, and timer. First, you can see in the first line, we have push button 1 and coil LED. So we call this as normally open. And then we try to simulate this PLC ladder diagram. When we give a true value or we press the push button, the LED coil will turn on. And when we give a false value, the LED will turn off. And then in the second line, we have normally closed contact. So the initial condition of this contact is closed. When we haven't pressed the button, the voltage is flowing through this contact and turn on the LED coil. But when we press the button, the LED will turn off. We have the understanding of normally open and normally closed. Now we are moving to the latching diagram. We can see here we have push button 3, emergency button, and relay. We have a normally open push button. Then we give a true value. It will turn on the relay. Then we have here a relay normally open contact. This is what we call as latching diagram. So the purpose of this latching diagram, it will still turn on even though the push button is not actuated like this. The voltage will still flowing through this line, and relay is still turning on. As we can see here, the relay will turn on the LED. And if we turn off the relay by actuating the emergency button, the LED 4 will turn on because it is a normally close contact from relay. And then we move to the timer ladder diagram. We have here the push button 4. Let's see what this timer do. This is a timer on, and for example we give time value to 2000 milliseconds. Give true value. After 2 seconds, the LED will turn on. And in the last line we have timer off. Let's see what it can do. When we give true value to the push button, the voltage will flow from this line to the LED. Then when we give false value to in this contact, after 2 seconds, the LED will turn off. So this is the basic PLC ladder diagram in the module 1. Then we move to the second module. Now I want to explain the module 2. The module 2 title is Automated Valve Control with Proximity Sensor. The objectives of this module are to understand how proximity sensor works and to understand how to control the valve in sequence in the system. A proximity sensor is a sensor that is able to detect the presence of nearby object without any physical contact. In this module, we need the proximity sensor to detect if there is an object nearby. When the sensor detects an object, then it will actuate the valve, then the sequence continues until the end of the process. The car system is divided into 4 stages. The first stage, when the first proximity sensor detects the car, the valve opens and soapy water will pour. The second valve opens and the first valve closes when the second proximity sensor detects the car. The clean water is poured on this stage. Then the third proximity sensor detects, the second valve is closed and the blower is turned on for drying process. And in the last stage, when the fourth proximity sensor detects the car, the blower will turn off and the conveyor will be stopped after a few moments. We click the module 2 here and we try to simulate. So the proximity sensor here is S1. When the first sensor detects the car, we will give a true value, then it will turn on the relay 1. relay 1 actuate and turn on the valve 1. And then the car moves to the second stage. The proximity sensor will detect the car. The relay 2 will turn on the valve 2. And we move to the third stage. Proximity sensor 3 detects the car. And same thing also happens like before. Then we move to the fourth stage. The fourth proximity sensor will turn on the relay 4. And as you can see here, all of the valve is turned off because the proximity sensor does not detect the car. Okay, now I will explain the module 3. Module 3 title is Water Temperature Control System. The objectives of this module are to understand how temperature sensor works, how to control regulator system works, and to understand object transportation using conveyor. So first we need to know what is a temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts it into a data, and then we input it into electronic data to record, monitor, or signal temperature change. There are many different types of temperature sensor. Some temperature sensors require direct contact with the physical object that is being monitored, while others indirectly measure the temperature of an object. Non-contact temperature sensors are usually infrared sensors. They remotely detect the infrared energy emitted by an object and send a signal to a calibrated electronic circuit that determines the object's temperature. This module purpose is to make an automated water temperature control system. The purpose of this system is to maintain the water at a certain temperature by turning on and off the heater at a specific moment. We can measure the temperature of water using the temperature sensor. You can see the chart here. We have a water tank in the heater, and we put the temperature sensor on water tank to measure the temperature of water, and we calibrate the data that we collect from this temperature sensor to the controller. In this case we use PLC, and then at a certain moment it will turn on the relay and turn on the heater. Now we move to the PLC ladder diagram in the Open PLC editor program. Click the module 3. You can see here it is pretty simple. So the controller or the PLC will give a signal when should the heater turn on and turn off. And we try to simulate this ladder diagram. After the PLC turn on the relay, it will turn on the heater. And in this module we also control the blower and the conveyor. When after the stage 4 finish, the blower will turn off. We need to actuate first the system on to start the overall sequence of the car wash system. So that is the explanation from me. Thank you.
Hello, my name is Gatrich Tanaka from Mechatronics 5 student, and today I'm going to talk about Module 4. And Module 4 is to make HMI for controlling the Module 2 and 3. And the objective of this module is to provide an HMI to display the temperature of the water, the blower temperature, and as the control panel. And also, we are going to install and use MQTT and Node-RED. The HMI not only gives you a breaker control from the remote and safe distance, but it provides a near real-time feedback on system-wide response to your control action, such as temperature sensor that we used in Module 3. And we will utilize Node-RED as an HMI, and Node-RED is a programming tool of wiring together hardware devices, APIs, and online services. Also, we are going to use MQTT to communicate. And MQTT is an open OSIS and ISO standard lightweight publish subscribe network protocol that transport messages between devices. Below are the procedures to download and install and how to use the softwares. In this module, the group will be given a task to make the HMI of Module 2 and 3, and this is how it will look like. So there's the temperature, the sensors, the relays, the valves, blower, conveyors, input, output, and this will this will be the result of the HMI. One is module 5. In this module, we are going to combine all modules into one system. And the objective is to make ladder diagram in module 2 and 3 into Arduino programming language and simulate using Node-RED as the HMI. In this module, after making the PLC ladder diagram in module 2 and 3, we are going to communicate both of the module, the car wash system to work. And this is done by using microcontroller because PLC is expensive. And we are using ESP8266 because it has a built-in Wi-Fi module and it is applicable in various IoT applications. And we will also learn how to convert PLC diagram to Arduino by using Logic Gate. And these are the equipment used. We will have two ESP module for the two module and two breadboard, jumper wires, buttons, resistors, LEDs, and the softwares that we are using in the previous module. And to convert the ladder diagram from module 2 and 3 to Arduino programming language, we will use a simple logic gate such as AND, NOT, and OR. And if the contacts have a series connection in the ladder diagram, it is an AND logic, and if a parallel connection, it is an OR logic. And this is the circuit diagram that we need to create for module 2 and module 3. In the module 2, we have 4 buttons as inputs, which is to replace the sensors that we are using as the input in the PLC ladder diagram, and we are using 3 LEDs and resistors. This is for the output of the module 2, which is the valves. And for the module 3, we are using 2 inputs and 3 outputs. The 2 inputs are the relay R1 and relay R4, and the outputs are the blower, the contactor C1, and the conveyor. And that's all for for the module 4 and 5.